Alright, so we've already talked about the basic structure of an amino acid. Let's go ahead and review that real quick. We'll draw our alpha carbon, our hydrogen, our carboxyl group, and our amino group. Okay, but today this lesson is going to be about this R group. Okay, this is really what gives an amino acid its identity. This, what we call the side chain group. Now there are 20 possible side chain groups, okay, giving us the possibility of 20 amino acids. All right. And there's really two major families that help us to break this down. There is our hydrophobic family, and then there is our hydrophilic family. Now, just to review what these words mean, hydrophobic is really two words. Hydro, which is in both hydrophobic and hydrophilic, really just means water. All right, we know that. But phobic means fearing. Think of a phobia that people have, agoraphobia, so they're afraid of being in public, or arachnophobia, they're afraid of spiders. If something is hydrophobic, it means it is water fearing. Let me erase this real quick. It means water fearing. But if something is hydrophilic, it would be the opposite. Philic means love. So water loving. Okay. These are also known, hydrophobic would also be known as nonpolar, and hydrophilic would be known as polar. Now the reason that this is, or why we call them nonpolar and polar, or hydrophobic and hydrophilic, let's think about the structure of water. So we'll draw the structure of water here. It has two hydrogens and one oxygen. But you notice that this isn't a linear structure. It's not hydrogen, oxygen, hydrogen just in one straight line. You notice that both hydrogens fall to the same side. Now what this does is this gives it a quasi-polar structure, where the side with the hydrogens is kind of positive and the side with the oxygen is kind of negative. And so whenever they're attracted to things, this side is kind of let's just say there's a negative ion, then the positive side, both of these hydrogens, would be attracted to negative. Likewise, this oxygen, if there was a positive cation, then this would be attracted to that. All right. So whenever we're thinking about these things, what would water love, or what would be water loving, what would be hydrophilic? We have to think about things that make sense. So based on this, we've said ions would make sense. So anything that would be ions. So something like an O negative or an N positive. Remember, we talked about things like this right up here. Likewise, water is going to be attracted to things that are like itself. So things that contain oxygen. Things like alcohols or ethers or aldehydes or ketones, etc. On the contrary, things that are going to be hydrophobic are things that are not going to be polar. So things that are going to be non-polar. So things that like are carbon-based and nothing else, or maybe just carbon and hydrogen only, or things that might be like sulfur, okay, or non-ionic nitrogen, okay, because we know that nitrogen normally in the form of ammonia, can be pretty symmetrical. Okay, if you drew a line down right there, it's going to look the same on both sides. Right, or likewise, if you drew a line right there or right there, it's going to be pretty much the same on both sides. So in the next lesson, we'll talk about different specific types of hydrophobic side chains, and then in the lesson after that, we'll talk about the hydrophilic side chains.